three resistors of 2 ohms, 3 ohms and 4 ohms are connected in series and parallel. Find the equivalent resistance in each case. So let's take up first the series. We have 3 resistors. One is 2 ohms, 3 ohms and 4 ohms, and they're connected in series. So series means end to end. So 1 here, 2 and 3. This is 2 ohms, 3 ohms, 4 ohms connected in series. So when it is in series, we have seen the formula. The resultant R is R1 plus R2 plus R3. So the resultant R is 2 plus 3 plus 4. So the R now becomes 9 ohms. And the next case, they've said they are connected in parallel. So in a parallel connection, we have already learned, parallel connection will be like this, all connected to the same point here. This is parallel, and then it is connected to a cell and to a battery. This is parallel connection. You have 2 ohms here, you have 3 ohms here and 4 ohms here. And in parallel, the calculation is 1 by R equal to 1 by R1, 1 by R2, 1 by R3. So 1 by R is 1 by 2 plus 1 by 3 plus 1 by 4. So we take the LCM of 2, 3 and 4, and that is 12. So this becomes into 6 into 6, here into 4 into 4 into 3 into 3. So that becomes now here 12. So 1 by R will be 22 over 12. So your R will be 12 by 22. Here it should be 3. So here will be 13 over 12. So this will be now 12 by 13 ohms. Now for these sums too, we need to calculate the equivalent resistance. Look at the first sum. Here we have R1 and we have R2. Now we know R1, R2 are connected in series because they're end to end. So the resultant of that will be R will be R1 plus R2, which will be 6 plus 6. So R will be now 12 ohms. Now I'll draw the figure again, and when I draw the figure again here I'm going to put 12 ohms because this is the resultant is 12 ohms. So this is my figure. This is 6 plus 6, the 12 came here, and this is 6. Now I will mark this. Now if you notice here, the 12 ohms and 6 ohms are connected in parallel. So I use the formula 1 by R equal to 1 by R1 plus 1 by R2. So 1 by R equal to 1 by 12 plus 1 by 6. So 1 by R, LCM is 12. So 1 plus 2. So you see 1 by R, 3 by 12, and your R would be 12 by 3. So it is 4 ohms. For the second sum, here just to repeat this again, we first started this, right? Here these were in series, so we added up and we got equal to 12 ohms. So the 12 ohms, we wrote it out here. This was made up of 2 resistances put end to end. Now the 12 ohms and the 6 ohms were connected in parallel. Now for the second one, we see here this 6 ohms and this 6 ohms are connected in parallel. So we'll just work the resultant of this 6 ohms connected in parallel. So 6 ohms connected in parallel, which means the resultant will be 1 by R. It's a parallel formula, 1 by 6 plus 1 by 6. So 1 by R, this will be 2 by 6. So 1 by R will be, this cancels, 1 by 3, and the R will be 3. So the resultant of this is 3 ohms, and the resultant of this will also be 3 ohms. So if I were to draw this figure again, I would have drawn like this. I would have got this, then now this would be 3 ohms, then here, and now this again, and we will have this here. This would be 3 ohms like we have already calculated, and this will be again 3 ohms. Now 3 ohms and 3 ohms connected in series. So if they are connected in series, we have R equal to 3 plus 3, and so R, the resultant here is 6 ohms. So in this case, you have to first calculate one combination and the other. We first calculated this combination here, then we calculated the blue one, and both of them were then added up. Just to repeat it, we did this here, we added this up, this we made 12 ohms. Then the other two were connected in series, and for this one we calculated this were in parallel, so this calculation came as 3 ohms, and this calculation, we use the parallel formula, came as 3 ohms. 3 resistors each of 2 ohms are connected together so that the total resistance is 3 ohms. So in this I have 3 resistance of 2 ohms. One, this 2 ohms, 2 ohms, and I need to connect them so that the resultant R becomes 3 ohms. So if I connect them in series, suppose I connect them, let me see. If I connect them in series, my R will be what? R1 plus R2 plus R3 will be 2 plus 2 plus 2. It will be 6 ohms. This is not what I want. If I connect them in parallel, it will be 1 by R equal to 1 by 2 plus 1 by 2 plus 1 by 2. So 3 times 1 by 2, that is 3 by 2, that is 1.5. So this also is not what I want. I want 3 ohms. So here this is just hit and trial. So I think probably you need to do this, a combination of both. So you need to do this and this, like this. So this is 2 ohms, 2 ohms, and 2 ohms. So first let us calculate this here. What is the resultant of this? So we see 2 ohms are connected in parallel. So the resultant of this 1 by R will be 1 by 2 plus 1 by 2 by using the formula. So 1 by R is 2 times 1 by 2. So I continue here, R equal to 1 ohm. So let me draw my figure again. So now here I'm going to make here 1 ohm. This will be my 1 ohm because I've calculated it. And then I have the 2 ohms here. The resultant of this is 1 ohm, which I have put here. Now the resultant of both these will be 1 ohm plus 2 ohm because both are connected in series. So I have now 3 ohms. So the answer was connecting 2 in parallel and then 1 in series. So this connection will now give you, this connection will now give a resultant of 3 ohms. So here's a circuit diagram given. We got to calculate the total resistance. Here the R1 is given as 10 ohms. Then we have R2 here, which is 40 ohms. R3 is 30 ohms. R4 is 20 ohms. And then here we have last 60 ohms. We'll start our calculations with this part, R1 and R2. Here R1 and R2, and we see that R1 and R2, just write it up here now, R1, R2 are connected in parallel, which means 1 by R equal to 1 by R1 plus 1 by R2. So 1 by R, 1 by 10 plus 1 by 40. 1 by R, the LCM will be 40. So 4 plus 1, 1 by R, 5 by 40, and your R will be 8 ohms. So the equivalent of this is 8 ohms. In the same manner, let us find the equivalent of these three. These three are again connected in parallel. So I will just write here the next part. So I have 1 by R, 1 by 30 plus 1 by 20 plus 1 by 60, because they are connected in parallel. LCM here again is 60. This would be now 2 plus 3 plus 1. So 1 by R will be 6 over 60. So R will be 60 by 6, and that is 10 ohms. So the equivalent of this is 10 ohms. Now if I redraw this, I'm going to put, and I know this is 8 ohms, I have already calculated, and in this lower one, this equivalent is, I've already calculated as 10 ohms. Now 8 ohms and 10 ohms, are they in series or in parallel? To find out this, let us see the path of the current. This is the path of the current. The same current is flowing through 8 and 10. So I can say, if the same current, 8 ohms and 10 ohms are in series. So the resultant will be 8 plus 10, and that is 18 ohms will be the resultant of this full circuit. Now to calculate the current, we know V equal to IR. The V is given as 12, here it is 12. The I we need to calculate, the R we have seen is already 18. So the current in this circuit will be 12 over 18 amperes. To summarize the sum, first we did, this was in parallel, we calculated using the parallel formula, and then we had, this was also in parallel, we calculated using the parallel formula. Then the blue and the green were in series, so we used the series formula.